Good morning, everyone.
Good morning, sir.
Good morning. Good morning. अटेंडेंस शुरू हो गई? हाँ, रिकॉर्डिंग तो चल रहा है. ठीक है. Let everyone join. Then we start the class in just 1 minute or 2 minutes. सबका खत्म हो जाने दो.
Good morning, sir.
Good morning, sir.
Good morning. Good morning. Good morning. 2 minutes we'll start class.
Good morning, sir.
Good morning. Good morning. Hello, Agad sir. All right, so the full class is here. Let us begin our class. Yesterday we talked about the relevance of rate of turn indicator. Why is it necessary? What are the IMO recommendation for passage plan and the courses? Repeating once again, courses have to be laid down as a straight line or as an arc of a circle with wheel over point marked. Wheel over point is the point where we are going to apply the helm so that the vessel will turn. After some distance, she will start turning and she will follow the course. As a navigator, it is our duty to keep the vessel on track as per plan. We should not go left and right of the port and starboard of the track. As far as practicable, we should keep the vessel on track. When we are on the straight course, we keep watching the course. Either we maintain the course using autopilot or hand steering. And after a certain time, we keep on plotting the position just to see whether the position is right on track or not. If it is gone to veer to starboard or port, then we give correcting helm and try to bring it back to the track. But during turn, it is not possible to watch the course because it is constantly changing. So that's where the rate of turn indicator comes. Because instantaneously I won't be able to watch any course. So I see how much of turn she is going to take in 1 minute, how much of alteration. So we get the rate of turn per minute. In 1 minute, she's going to change her course to so much, then next minute, then next minute, then next minute. So it is basically the time required to make the turn and how much of turn. ROT is equal to theta by t or alteration angle divided by time taken to execute that. Yesterday we have seen that the time taken will depend on number one, the distance she is going to travel, and also the speed. More the distance, more the time. Time is proportional to the distance. Inversely proportional is the speed. The time taken will be less if the speed is more. Time taken will be more if the speed is less. So these are the two factors on which the time will depend, the distance d and the v. So we have got to find out some relationship between all this, and for that we need to have a formula accommodating these time, the speed, the distance, etc., etc. So in this connection, yesterday we had talked about the arc of the circle. उसके लिए distance का कुछ rule बताया था. If we know the angle at the center, then we can find out the length. Think of yesterday's class and try to do this math, small, very simple math. If the angle subtended at the center by two radiuses are 1.5 radians, if the angle subtended here between two radiuses is 1.5 radians, how much is the distance? How much is the length of the arc? Anyone?
अरे एक बार बोर्ड पे करा दिया.
Come again? Board पे बताऊं?
Yes, sir.
Okay, 1 second. Let me set up the camera. All right, board visible?
114.6.
Okay, just 1 second. What we said is the angle subtended at the center is 1.5 radian. Radians can be shown as RAD or it can be shown as 1.5 अगर बोले RAD और 1.5 C. ऊपर में C लिखेंगे तो that is meaning radian. If this is 1.5 radian, how much is the length of the arc? Given that the radius is r. कल ये हमने डिस्कस किया था. I wanted to remember and understand that. Yes. Anyone? Quick. Don't waste time.
1.5 r square.
R square नहीं, बस 1.5 r. 1.5 r. That's all. Because we know already that if the angle is 1 radian, then the distance is r. That means what we say, if the arc is of length r, then the angle subtended is 1 radian. That is what we did yesterday, right?
Yes, sir.
That means T is equal to R into alpha, where alpha is in radians. अगर ये alpha है, alpha radians, so multiplied by that. अगर 1.5 है तो 1.5 R, अगर 2 है तो 2 R, अगर 3 है तो 3 R, और अगर पूरा हाफ सर्किल होगा तो कितना R होगा?
3.14.
3.14 pi R. That is why we say that the circle, the circumference and radius ka ratio is 3.14, or rather 2 pi r. The length of the perimeter is 2 pi r. This is the standard relationship. पहले भी बात किया था, छोटा सर्किल हो तो भी यही रिलेशन, अगर बड़ा सर्किल हो तो भी यही, और बड़ा सर्किल हो तो भी यही रिलेशन. जैसे जैसे ये बड़ा होगा, ये बड़ा होगा. So this is the standard relationship. T is equal to R into alpha. Now if we want to convert, supposing if you have 1.5 radian, how many degrees? Because degrees is the normal unit of the angle that we use. So radian should be converted to what we use generally, the degrees.
57.3.
35.94.
57.1 radian is equal to 57.3 degrees. So 1.5 is equal to 1.5.
35.9, sir.
85 degree 57 minute.
Very good. Ekdam sahi baat. So now we are going to derive the formula for this relationship. Remember that when turning the vessel, the distance is a direct function of the radius. This distance d is not only the angle but also of the r. अगर r छोटा होगा तो distance भी छोटा होगा. r बड़ा होगा तो distance भी बड़ा होगा. That we have already seen. So in this figure, the distance d is equal to r into alpha, where alpha in radian, correct? Correct. It is equal to r into theta by 57.3, where theta in degrees. Think about it and see if it is okay. If not, I'll explain. ये क्या हो गया? Confusion?
Yes, sir.
Yes, sir.
Supposing this was 1 radian. So D is equal to R into 1. ये ठीक है?
हाँ sir.
Okay. Now we know that if we convert this into degrees, R into 57.3, 1 radian is 57.3 degrees, correct?
Yes, sir.
अगर इसको 57.3 से डिवाइड कर देंगे तो कितना हो गया वैल्यू?
1.
तो थीटा में हमने थीटा डाल दिया, थीटा की जगह थीटा डाल दिया, मतलब यहाँ पे, और उसको 57.3 से डिवाइड कर दिया, तो ये वैल्यू तो वही रह गई. ये बेसिकली रेडियन वैल्यू ही है.
Yes, sir.
अगर हमारे पास ये 1.5 होता रेडियन, अभी आपने मुझको बताया कि 84.9 डिग्रीज है. 84 या 86 कितना बताया था आपने? 1.5 का
Sir, 85.9.
85.9. सो मान लीजिए हमने कहा इंटू 1.5 रेडियन. दैट मीन्स इसको अगर हम कन्वर्ट कर दें डिग्रीज में, तो दिस विल बी आर इंटू 85.9 डिग्रीज डिवाइडेड बाय 57.3. मतलब ये 1.5 हो गया है नहीं?
हाँ sir.
Yes, sir.
तो अब ये ठीक है कि पहले हमने रेडियंस में लिया था, रेडियंस को थीटा में अगर हम देखते हैं तो उसको डिवाइड कर देंगे 57.3 से, तो हमारा वैल्यू बेसिकली आर का ही वैल्यू रहेगा, मतलब अल्फा का ही वैल्यू रहेगा. दिस
Yes, sir.
So now it is okay. Now it
Yes,
is
sir.
okay.
Yes, sir.
Okay, good. So let us take this to be equation number 1. We also know t is equal to speed into time. Distance traveled is speed into time. Is that correct?
Yes, sir.
That means t is equal to t by v, where v in knots. Knots is basically speed per hour, nautical miles per hour. Correct?
Yes,
Yes,
sir.
sir.
All right. So taking it forward, d की वैल्यू अगर हम यहाँ पे डाल दें, d की वैल्यू क्या है?
R theta by 57.3.
Okay, so that means t is equal to r into t की वैल्यू अगर डालें यहाँ पे, तो this will be d this into divided by r theta 57.3. Is that correct? नहीं, क्या करता हूँ मैं?
क्या कर रहे हो सर?
R theta into 50 divided by 57.3 into 1 by b. Correct?
Yes, sir.
Yes, sir.
Now this is in nautical miles. 1 घंटे का टाइम में इतना चलता है, तो 1 घंटे का टाइम तो मुझको चाहिए नहीं, मुझको तो मिनट का टाइम चाहिए था, छोटा यूनिट चाहिए. So should I divide it by 60? Then it will become time in minutes.
Yes, sir.
ये अभी
That's
किस में
right.
है इसका टाइम?
Then come again.
सर ये अभी टाइम किस में है, कौन सी यूनिट में?
V तो हम जो स्पीड लेते हैं शिप का, किस में लेते हैं नॉर्मली?
सर टाइम पूछ रहे हैं, टाइम.
टाइम अभी ये टाइम जो है वो तो घंटे का टाइम निकलेगा, क्योंकि ये
Yes,
हमने
ठीक है.
डिस्टेंस निकाला है. स्पीड इन 1 आवर, मतलब स्पीड इन 1 आवर वी टेकन ना. सो दिस इज
हाँ सर,
टाइम इज आवर. तो
सर ये
उसको
D जो है ये V into T upon R नहीं होगा?
कम अगेन.
ये D is equal to V into T लिखा है आपने, ये V into T upon R नहीं होगा सर?
V into T अपॉन R. अभी तो R हम आए नहीं ना है, R की वैल्यू तो हम डाल ही रहे हैं ना यहाँ. T की वैल्यू हम डाल रहे हैं भाई. ये डिस्टेंस जहाज चल रही है यहाँ पे, चलते हुए इतना डिस्टेंस ट्रैवल किया कि नहीं इसने?
Yes,
यहाँ
sir.
से यहाँ तक का डिस्टेंस ट्रैवल किया कि नहीं, which is D.
Yes, sir. Yes,
And
sir.
that D is this much.
Yes, sir.
और उसमें टाइम जो लगेगा that will be related to this equation.
Yes, sir.
जिसमें टाइम का भी फैक्टर, स्पीड का भी फैक्टर ले रहे हैं हम.
Yes, sir.
तो D की वैल्यू हमने इसी इक्वेशन में डाल दी. T is equal to so and so किया, तो T की वैल्यू हमने डाल दी. T is equal to R theta by 57.3 into 1 by V. Is that correct?
Yes, sir.
But this T is in hours, correct? This T is in hours. नहीं समझ में आया?
हाँ यस सर.
तो अब अगर टाइम हम इन मिनट्स निकालें, तो will that be the same thing divided by 60? एक घंटे में आप 60 किलोमीटर चलते हैं. एक घंटे में आप 60 किलोमीटर चलते हैं, तो एक मिनट में कितना चलेंगे?
1 किलोमीटर.
1 किलोमीटर.
डिवाइडेड बाय 60 करेंगे ना. जो स्पीड थी आपकी v को आप 60 से डिवाइड करेंगे ना मिनट में निकालने के लिए.
हाँ सर ये तो
Yes,
समझ
sir.
गए.
तो ये v जो है दैट वाज इन 1 आवर, नॉटिकल माइल्स इन 1 आवर, उसको डिवाइड करेंगे तो मिनट का टाइम निकलेगा या नहीं?
यस सर ठीक है।
अब समझ में आ गया? सो दिस 60 विल गो अप। मैं इसको फेयर में कर दूंगा एक बार, अगर कंफ्यूजन हो रहा है तो फेयर में ऊपर से नीचे लिख दूंगा, छोटी जगह है। तो दिस गोज 60 लाइक दिस। यहां तक ठीक है?
यस सर।
ओके, नाउ इसको हम फ्रेश में ऊपर से नीचे फिर से लिखते हैं, थोड़ा छोटा छोटा करके, ताकि सारा कुछ एक बोर्ड पे आ जाए। We know T is equal to R into alpha, where alpha in radians is equal to R theta by 57.3, where theta in degrees. Also, T is equal to V into T. That is to say, T is equal to D by V. This is in R's. This T is equal to D into 60 divided by V. That is T in minutes. Is it okay? हमने इसको 60 से डिवाइड कर दिया, तो 60 वाला ऊपर चला गया। Is it okay?
ओके सर।
All right. So this further gives, putting the value of D here, जो D यहाँ पे है, this is equal to R theta by 57.3 into 60 by V. Is that okay?
यस सर।
Yes, sir.
Okay. So now we know ROT is equal to theta by T. Is that correct?
यस सर।
जो angle of rotation, हाँ?
सर आर थीटा बाई 57.3 ये टी का वैल्यू है ना सर?
कौन सा ये?
यस सर।
ये यहाँ पे जो D है वो D यहाँ पे है या नहीं? D is equal to so much.
यस सर, और डी का वैल्यू है। ओके
और D का वैल्यू हमने यहाँ वाला इसमें डाल दिया।
यस सर।
D की वैल्यू डाल दी, जो D की वैल्यू थी, जो D की वैल्यू निकाली थी यहाँ, वही वैल्यू यहाँ डाल दिया।
यस सर, समझ गया। थैंक यू।
ROT is equal to theta by T. Is that correct or not?
यस सर।
Correct, sir.
Means this gives you the value theta को डिवाइड कर देंगे इस T से, because T is equal to so much, तो ये R theta 60 यहाँ जाएगा, और जो नीचे वाली 57V है वो ऊपर चला जाएगा। करेक्ट?
यस
यस
सर।
सर।
हमने T से डिवाइड कर दिया थीटा को, तो थीटा ये तो रह गया यहाँ पे, T की वैल्यू की जगह हमने इसको यहाँ पे उठा कर रख दिया, तो ये वाली चीजें नीचे आएंगी और नीचे वाला ऊपर चला जाएगा यहाँ।
यस सर।
Yes.
So theta theta cancel. So what do we have? This gives us ROT is equal to V by R into 57.3 divided by 60. Is that okay or not?
यस सर।
This is very much approximately equal to V by R. Correct?
ये
क्योंकि
यस सर।
57.3 by 60 is how much?
0.955.
955. So almost equal to 1.
Yes, sir.
Yes, sir.
So what we have, ROT is equal to V by R. This is the relationship of the ROT required for getting a turn. You see your speed, you see the radius of the turn, and divided by that, you calculate the ROT. Note down this. When you are done, let me know.
सर ये भी पूछता है क्या, डेरिवेशन भी पूछता है?
हो सकता है, हालांकि डेरिवेशन नहीं पूछेंगे, बट आपके कोर्स में है तो वो बताना जरूरी है. दो स्टेप का है. टी आर अल्फा डी इज इक्वल टू सो मच सो, फिर दूसरे पॉइंट में डी इज इक्वल टू ऑल्सो दिस, उससे हम डी टी की वैल्यू निकाल लेते हैं और थीटा बाई टी कर देते हैं बस. फिनिश्ड. Okay.
Yes, sir.
All right. So now that we know the ROT, ये ROT जो हमने निकाला इसका क्या मीनिंग है? That if you are coming at a speed of v, यहाँ पे आप आ रहे हैं, आपको यहाँ से टर्न करना है, तो आप somewhere you will give the helm, आगे जहाज जाकर के घूमने शुरू हो जाएगी, यहाँ पे टर्न करना शुरू होएगा. आप रेट ऑफ टर्न इंडिकेटर को देखेंगे और इसमें आपको वैल्यू चाहिए कि आपको कितना टर्न ऑब्टेन करना है यहाँ पे. तो आप यहाँ से इस टर्न का रेडियस देखेंगे. रेडियस कितना है? लेट अस से रेडियस इज 2 miles and the speed is 14 knots. Then what is the ROT that you require for this, making this turn? What is the ROT required for you?
6, 7,
Come again? 7
7,
degrees.
sir.
ROT is equal to V by R is equal to 14 by 2 is equal to 7 degrees per minute. So when you are giving rudder, your objective is to obtain the ROT of 7 degrees. जैसे ये 7 degrees के टर्न पे शुरू हो जाती है, वैसे आप रडर को मेंटेन करेंगे 7 degrees, 7 degrees, 7 degrees, 7 degrees, 7 degrees. You will be almost going on this track. क्लियर? कोई डाउट है तो पूछो अभी. Any doubts?
No, sir.
सर ये आर बड़ा अजीब लग रहा है, मतलब
क्या अजीब लग रहा है
आर
इसमें?
कैसे लेंगे और कहाँ से लेंगे?
Okay, very good question. Very good question. R कहाँ से आएगा? Supposing this is your chart. This is chart, lat longs are there, and you have to pass through. This is the shoreline. There is an island here. There are buoys. So when you are coming here in this place, you have to take your vessel and pass like this. Is that okay? आप चार्ट में देखिए ये कोर्स डाल रहे हैं. Is that okay?
Yes, sir.
Okay. So now you are having to turn here the radius of turn will be this. That means you are going to keep some distance away from this object. Is that correct?
Yes, sir.
Okay. So जितनी जगह होगी उसके हिसाब से R डालेंगे आप.
Sir, please repeat.
Either you have an object जिससे आपको एक distance maintain करके turn करना है.
हाँ सर.
Sir, नहीं, अगर ना हो ऑब्जेक्ट तो सर.
Okay. Again, coming to that. Good questions. These are all good questions. Now, what is happening? The value of R is not available in any book.
माँ
माँ को बुला रहा है कोई. All right. I can turn my bike very close, very tight turn. I can turn like this. Can I turn the truck also in the same manner?
No, sir.
No. The bike handle, I can turn only this much. So that will go longer. The other one I can turn more. So will there be difference?
Yes, sir.
Radius of turn or the turning circle? So the limiting factor for radius, the ideas that we have to keep in our head for deciding the radius. The radius is decided by the navigator who is making the plan. कैसे turn करना है, कितना radius रखना है, it is to be done by you. You will consult the master, of course, but it has to be done by you, the navigator. What are the things to consider? Whether I have big vessel or small vessel. Small vessel turning easy, big vessel not turning so easy, goes longer. So radius has to be big for VLCCs and those kind of vessels. But if it is small vessel like 100 meters, 120 meters or so, you can take a sharper turn. But that sharper turn will also be depending on the effectiveness of the rudder. आपका rudder कितना effective है? So not only that, the turning of the vessel is affected by loading condition also. अगर जहाज loaded है तो थोड़ा लंबा में घूमती है, अगर light है तो जल्दी घूम जाती है. Also the type of vessel. There are certain types of vessel जिनका bow बहुत narrow होता है. Passenger vessels, containers, उनका narrow bow होता है. Bulk carriers, उनका bow चौड़ा होता है. जिनका चौड़ा होता है उनको घूमने में टाइम लगता है, बट जो नैरो है they cut through the water easy and can turn easy. So type of vessel, narrow bow के vessel को we call it fine form vessel, and the one which is having a bulbous bow, not bulbous only, wide bow, is called full form, fine form and full form vessel. पढ़ लिया आपने ब्लॉक कोएफिशिएंट?
नहीं सर, अभी नहीं स्टार्ट हुआ.
अभी नहीं हुआ. तो ये हाउ मच वाटर इज रिप्लेस्ड बाय द डिस्प्लेस्ड बाय द हल ऑफ द शिप, ब्लॉक कोएफिशिएंट जैसी कुछ चीज होती है, वहां पे आपको ज्यादा समझ में आएगा. अभी के लिए इतना समझ लीजिए कि नैरो वेसल्स जो होंगे जिनका बाव नैरो होगा दे कैन टर्न इजी, जिनका चौड़ा होगा बाव लाइक बल्क कैरियर्स वो थोड़ा डिफिकल्टी से टर्न करते. So the factors that you have to consider in deciding the radius is the type of vessel, the size, length of the vessel, the width of the vessel, the rudder effectiveness, displacement, that is loading condition, then also the sea room availability,
Yes.
how much of area you have available, proximity to hazards, कि इस तरफ में क्या है,
Yes, sir.
all considered, you have to decide the radius.
Sir, depth also.
Come again, depth, yes, very good, depth available. Also the shallow water effect, if the depth is less, the turning circle increases. In deep water, the vessel will turn comparatively easy. अगर shallow water हो गई तो वहां पे rudder का effectiveness कम हो जाता है, turning circle बड़ा हो जाता है. So shallow water effect, depth of the water, very good point. All this must be considered in deciding the radius. The master has got a lot of experience. So when you decide this radius, you consult with the master and tell him that this is what I have considered in this, deciding on this. Please tell me if it is okay. He says, gives you go ahead. Yes, good, no problem. Have you considered this? Have you considered this? Have you considered this? Yes, sir. Now we are loaded. So I'm taking this little longer radius. Understood? So the factors that decide the radius the factors that will decide the radius. The type of the shape, length overall, breadth of the shape, displacement, displacement, effectiveness of rudder, sea room, depth, proximity to hazard, etc., etc. Also maybe trim and list. All right.
यस सर, 1 मिनट रुकिएगा सर, नोट डाउन कर लेते हैं इनको.
Yes.
इसमें करंट का भी इफेक्ट पड़ेगा क्या सर?
क्या?
करंट का?
वो बाद में, करंट का फैक्टर आपको नहीं, करंट का फैक्टर होता है, बट इसमें डायरेक्टली अफेक्टेड नहीं होगा, लेकिन टर्निंग में करंट का इफेक्ट होता है, which we are going to do in phase 2, not here. हो गया?
यस सर.
All right. So when we are planning the turn, where we have to put the course as a straight line or as an arc of the circle, then we decide the radius considering all these factors in consultation with the master, because master has seen enough, he has lot of experience, so he will let you know whether your choice of the radius is good or there has to be certain kind of change. And change, you must ask him and learn from him why he is changing this, what he is considering, which probably you missed out. That will come from the experience. So voyage planning, passage planning has got 3 stages, rather 4 stages we can say. Appraisal, then planning, then execution, and then monitoring. You know that the plan, passage plan has to be ready from berth to berth, point to point. Passage plan should be ready before commencement of the voyage. So the steps that you are going to take is for the complete voyage is first appraisal, thinking of obtaining all information regarding the voyage, कहाँ से जाना है, कहाँ जाना है, किस तरफ के एरियाज वगैरह, चार्ट्स, ये सब सारी चीजें, और उनके बाद हम प्लानिंग करेंगे. प्लानिंग में हमने देख लिया कि देयर आर courses to be laid down considering all the factors, keeping the safety of the vessel in mind. Once we have planned, we start executing the passage. निकल पड़ते हैं हम अपने port of departure से, and then we are following the track. But during that progress, execution, we keep on monitoring whether we are on track or not. सही चल रहे हैं या नहीं. So appraisal को अभी हम छोड़ देते हैं. यहाँ पे हम सिर्फ टर्न की बात कर रहे हैं. We are not talking about the whole passage plan. वो कोई दूसरे सर पढ़ाते हैं आपको. But talking about the turn in specific, the turn also will have the following stages: planning, execution, and monitoring. These are the 3 stages of executing or getting to the turn. So first, the planning. We will talk about all the 3 points with respect to turning the vessel. Planning of the turn can be in 2 situations. When you have to plan the turn, there may be a radar object around which you are turning. You have some object and around which you are turning. So you have a radar conspicuous object which you can see on the radar. एक island है, एक buoy है, lighthouse है, कुछ ऐसी चीज है जहां जिसको आप रडार पे देख सकते हैं. So first condition of planning will be when you can see a radar object. So the first one is planning the turn around a radar conspicuous object, something that you can see on the radar. Conspicuous matlab visible. Other times it may be that you don't have anything on the radar, you can't see anything. There is a shallow patch here जहाँ पे depth कम है, but this is only on the chart mark किया हुआ है, contours mark किया हुआ है, but on the radar you can't see, so you have to turn. So the second type of planning will be when planning the turn around an imaginary point. There is nothing to see, so imaginary point. So these are the 2 conditions in which you have to plan the turn. Number 1, around a radar conspicuous object. Number 2, around an imaginary point. We will talk about these two methods one by one. So first one is planning the turn around a radar conspicuous object. I hope you have written down the two methods. Now suppose this is your chart. You have longitudes, you have latitudes. Maybe there is a shoreline and you have a small object which is visible to you. So the step to plan the turn around this object which is visible on the radar is first identify the object. जिसके अराउंड आपको टर्न करना, उसको ऑब्जेक्ट को आइडेंटिफाई कीजिए चार्ट में कि मैं इसके अराउंड टर्न करूंगा इस ऑब्जेक्ट के. Then second point is decide the radius. जो आपको रेडियस रखना है वो डिसाइड करेंगे. What are the considerations for deciding the radius?
All factors.
What are the considerations that you will have in your mind for deciding the radius?
सर लेंथ
Speed,
फ्री रूम हो गया सर.
अभी लिखवाया था. The type of
Length
vessel.
or displacement,
Displacement,
effectiveness of
Displacement,
radar.
effectiveness,
sea room available.
room, sea room available.
All things considered, you will decide the radius. So now you have decided the radius. Then keeping that radius and keeping this object as center O, draw an arc. Now that you have made the arc of radius R, which you have decided, compass rows पे जाइए और initial course and final course draw कर दीजिए. So 1, 2, that is deciding the radius 2, 3 is making an arc, then 4 draw the initial and final course passing tangential to the arc. So आपका कोर्स पीछे से आ ही रहा था, आपने उस कोर्स को इस टैंजेंट के साथ बना करके इसको टैंजेंट के जैसा सर्किल के साथ आपने खींच दिया. So this is your initial course. And this is your final course. So simple method, 4-step, identify the object, decide the radius, draw an arc, tangential to the arc, draw initial and final course. Are we good? Quickly take out the notes that I have given to you, the question bank. Open the rate of turn topic and find out that question, planning the turn around a radar conspicuous object. Quickly. Have you found out?
Yes, sir.
Okay. So take a look at that question where it says, how will you plan the turn around a radar conspicuous object? The answer is there. It is talking about identifying the object, deciding the radius, drawing an arc, then drawing the initial and final course, passing tangential to the arc. Is it okay? Yes, is it okay?
Yes, sir.
All right. Now, one thing I want you to note down before we go to the second part, I want you to note down this. No, not. If this was the center and this is the radius, what is, let us say this is A, B, and C. How do we find out the AB and how do we find out the BC? If we draw a line like this, there are two right angle triangles क्योंकि ये tangent है तो यहाँ पे 90 डिग्री बनेगा.
Yes, sir.
In this one is R, this one is R. This is 90 degree, this is 90 degree. And we are dissecting the, drawing this line BO, which is dividing this, which is common in both of these triangles. So are they congruent? ABO and BCO, they are congruent or not?
Yes, sir.
That means here we can say that AB is equal to BC.
Yes, sir.
Okay. Here this was theta. So this one is theta by 2. Is that correct?
Yes, sir.
Yes, sir.
All right. So in this triangle, how do we find out the value of AB, BC, which is equal? In this, we know that this is theta by 2. It is a right angle triangle. Tell me the value of AB.
Sir, R theta.
Theta?
R theta, sir.
Hey, R theta. R theta कहाँ से आ गए? हम इसकी बात कर रहे हैं, यहाँ की बात थोड़ी कर रहे हैं.
सर ओ भी साइन थीटा बाई 2.
Hey, we want the relationship between perpendicular and base, which is R.
R
Sir,
into
R
tan theta by 2.
Yes, this is equal to R tan theta by 2. AB is equal to BC is equal to R tan theta by 2. Everyone ascertain this. Verify that this is okay, understood or not. किसी को problem है, बात कीजिए. I will explain once again. Is everyone okay with this? Is everything okay?
सर एक बार फिर से समझा दीजिए.
सर एक बार फिर से समझा दीजिए सर. R tan theta.
Okay. Do we have this triangle? Is this R? Is this what we want to find out? Is this angle theta by 2? इसमें कोई दिक्कत आपको?
No sir.
No. This is a right angle triangle. So tan theta is equal to P by B. Is that okay? Perpendicular
Yes,
by
sir.
base.
हो
Here, tan theta की जगह हमारा क्या एंगल है? जो ऑल्ट्रेशन एंगल है थीटा, दिस एंगल इज हाउ मच?
थीटा बाय 2.
थीटा बाय 2.
Theta by 2 is equal to perpendicular. What is this perpendicular? Is it AB?
AB.
And what is this base?
Sir, radius.
Radius R. So AB is equal to R tan theta by 2. Is this okay or not?
Yes.
क्लियर हो गया? क्लियर हुआ या नहीं हुआ? नहीं हुआ तो फिर से बोलो. हाँ ना बोलोगे कुछ?
हो गया.
हो गया सर.
यस सर, हो गया.
क्लियर हो? ओके.
Okay, sir. Thank you.
The same thing, this one is r tan theta by 2, and this one also is r tan theta by 2. Why we did this? Why we did this r tan theta by 2 is to approach the second question of planning the turn around an imaginary object. The second point that we are talking is planning the turn around an imaginary point.
ये next class में करें.
हाँ करेंगे next class में, होगा time. So this will be doing in the next class. ठीक है?
Thank you, sir. Thank you, sir.
चलो ओके.
Thank you, sir.
Thank you, sir.
Thank you, sir.
रुक जा, चुप. अभी तक जो हमने किया, इज इट ऑल मेकिंग सेंस? सब पकड़ में आ रहा है या कहीं पे स्लिप हो रहा है आपसे कि नहीं पकड़ में आ रहा? इज इट ओके जो हम लोग कर रहे हैं?
यस सर.
Sir.
Yes, sir.
ठीक है. सो अगले क्लास में विल टॉक अबाउट दिस. वी विल हैव क्लास टुमारो आई सपोज. आज तो और क्लास नहीं है मेरे ख्याल से. So meeting you in the next class. Bye bye. Have a great day.
Thank you, sir.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Bye bye.